All right, this is actually lesson 2 from your textbook. And the reality is, I believe it's lesson 2. Yeah, lesson 2. The beginning of it is review. It's just exponents, and then it goes into 1, 2, 3, 4, like 5 or 6 different concepts. The first ones of these are all going to be review. One of them is silly because you need to work it a different way, which is the correct way to work it in my brain. And then the last one is going to be a little bit different that some of you may not have seen yet. So let's start working through all of these different concepts. Okay, I want to point out one thing here. You need to pay attention to parentheses when we're dealing with exponents. So if I have 2 squared versus negative 2 squared versus negative parenthesis 2 squared versus negative 2 squared. Let's talk about all of these things. Here's the thing. The exponent only affects what is directly in front of it. So in this case, I'm squaring the 2. 2 times 2 is 4. Now pay attention here, because this exponent is only going to affect what is directly in front of it. This is not directly in front of that exponent. So technically, I am not touching that negative. It is just staying put. And then I'm going to simply square the 2. And actually, this one doesn't even, we don't really need to even look at this one because that's not that confusing. But this one, the exponent will touch and deal with whatever is directly in front of it. But this negative 2 has a set of parentheses around it. Parentheses are kind of like the bread of a peanut butter and jelly sandwich. It pushes what is inside of it together and sort of forces it to be one thing. So while this exponent only affects what's directly in front of it, because of those parentheses holding the negative 2 together, in this case, I am squaring a negative 2. This negative is not being touched. But what I actually am doing here is negative 2 times negative 2, because those parentheses stick it together. So I'm going to keep this negative. Sorry, I'm going to do my answer right up here. This negative is not, oh goodness. This negative is not being touched. It's going to stay right here. Then negative 2 times negative 2 is positive 4. And we'll do another one of those in just a second. So let's look at another one of these. Let's talk about negative 3 squared versus negative 3 squared. Again, the exponent only affects what is directly in front of it. Directly in front of this 2 is simply a 3. This negative is not being touched, which means it's just going to stay put. And then I have 3 times 3, which gives me negative 9. Now the second example here, remember, the exponent deals with what's directly in front of it, but these parentheses stick the negative to the 3. So what this means is negative 3 times negative 3, which in this case is then positive 9. So really watch those parentheses, because whatever is inside of it gets stuck together and I can't pull it apart. It has to stay as one unit. I'm going to put a couple of these here for us to try as just a review. 3 to the 0 power, negative 3 to the first power, 6 squared, negative 6 squared, and then let's do negative 6 squared like this. What I would like for you to do is to work these problems, pause the video, work these problems, and then push play again and see if you have them right. Take a second and work these and then come back and check them. All right, let's talk about these answers. We have 3 to the 0 power. Remember, the rule is anything to the 0 power equals 1. Always and forever, anything to the 0 power equals 1. This 1 is going to affect this, but it is not going to affect this because there is no parenthesis keeping that negative stuck to the 3, so it's kind of like a separate entity. So what we're going to do is we're going to keep the negative, and then 3 to the first power is just 3. 6 squared is 6 times 6, which is 36. Negative 6 squared, this touches what's in front of it. This negative is not being touched, so we're going to just keep that, and then 6 squared is 36. All right, these parentheses, stick this negative 6 together. So what I really have is negative 6, oops, that's not a 6, times negative 6, which equals positive 36. All right, let me put a few problems on here for you guys to try. Let's do 16 to the third power times 16 to the fifth power. Then let's do 7 to the ninth power divided by 7 to the fourth power. That's not going to work. Divided by 7 to the third power, 7 cubed. Okay, remember, if you're multiplying like bases, you add the exponents. If you are dividing, you subtract. Multiply, add, divide, subtract. So try these two problems, and then pause it, try the two problems, then press play and check them. So let's talk about this first one. Remember, multiplying means we add exponents. 3 plus 5 is 8. So this is going to be 16 to the 8th power. And again, we're only being told to simplify, so we stop right there. On the second one, if we are dividing, we subtract. 9 minus 3 is 6. And because we're simplifying, we can leave it right there. Concept in this lesson for exponents is kind of silly because they teach you a different way to do this kind of problem. But here's the thing. Order of operations says we have to do parentheses first. They want you to expand this and do all of this stuff, which doesn't make any sense to my mathematical brain, because order of operations, parentheses, comes before exponents. So to work these, you simply work inside of your parentheses, and then you look at the outside. And this is just saying 15 squared. Now, if it's asking you to solve it, 15 times 15. If it's asking you to simplify it, it's just 15 squared. Okay, here are 1, 2, 3, 4, 5 practice problems. I would like for you to work these 5 problems independently, and then we're going to do them on this video. I'm going to work them out on the video and walk you through them. So, you know, if we're having to do this virtually. If we were in class together, I would make you all pull a piece of paper out, make you work these, and then we would check them together. So we're going to pretend that we're in class together. You're going to pull a piece of paper out. You're going to work these 5 problems. Pause the video, then push play, and let's check them. Okay. Let's work these problems. But all of you have already done them, so what we're going to do is we're going to be checking them, correct? All right. Anything to the 0 power is always and forever 1. Anything to the first power is always and forever itself. All right. Remember, if we are multiplying like bases, we add the exponents, so our base stays. 4 plus 3 is, whoops, that's not a 7. 4 plus 3 is 7. If we are dividing, we subtract. Our base stays. We subtract our exponents. 6 minus 4 is 2. And then on the last example, let's ignore the textbook way to do it and do the easier way, which I think is the exact same problem that I already did, but that's okay. 3 times 5 is 15, and we keep our exponent. All right, so when you have a number with a negative exponent, it's mathematically illegal, and I'm using air quotes around the word illegal because obviously it's mathematics, but you technically cannot work with a negative exponent. So when a number has a negative exponent, you simply take the reciprocal, which is just the flipped fraction form of the number. And when you flip it over, the sign of the exponent changes. Here's what that's a lot of words to say this. When an exponent flips over the fraction line, the sign of the exponent changes. All right, so 3 to the negative 3 to the negative 2. Step 1, and I'm going to try to write this in over here. If it's not a fraction, Make it a fraction. And that's written terribly. I can hardly write with this pen. So make it a fraction. I can make any number a fraction by putting it over 1. My value hasn't changed, and it's now a fraction. So that's kind of an if step, if you need it. And then the big step, you need to flip the fraction. When you do, the sign of the exponent, not the number, but the exponent changes. So if I take 3 to the negative 2 over 1 and I flip this fraction over, I don't know why I'm drawing that arrow, I use the reciprocal. You guys have worked with reciprocals forever. The reciprocal is just the flipped fraction. I'm going to flip it. The bottom becomes the top becomes the bottom, except when I flip it, the sign of the exponent changes. So instead of being negative 2, I now have 3 squared, which I can solve. This becomes 1/9, okay? So anytime an exponent changes the side of a fraction, the sign of the exponent changes. Now, when I have something on the outside of this, I'm going to give this to both pieces, because remember the parentheses sticks everything together. So what this becomes is 2 to the negative 3, 3 to the negative 3. Because there's a fraction inside of the parentheses and outside of the parentheses is an exponent, that exponent affects everything inside because the parentheses have stuck it together. But now my problem is I have negative exponents and I cannot work with negative exponents. So what am I going to do? I am going to flip. The top becomes the bottom becomes the top. And the sign of the exponent changes. So my negative 3 becomes a 3. My negative 2 becomes a positive 2. Now the sign of the number doesn't change. The base stays. Only the sign of the exponent. And now I have a problem I can solve. 3 squared is 9. 2 cubed is 8. And I can leave it just like that. So remember, make it a fraction, then flip it. I'm going to give you guys a couple to, let's see, let's do 2 to the negative 3, and then let's do 1/5 to the negative 2. So let's do this again. We're going to make it a fraction if needed. We do that by putting it over 1, and now we flip. The bottom becomes the top becomes the bottom. When this exponent flips sides, the sign changes and it becomes a positive. So this becomes 1/8. All right, so this next one, which is written quite terribly, I guess it doesn't matter what it looks like because you know what it is, but 1/5 to the negative 2 power. I'm going to distribute. Why am I doing that? I'm going to distribute that, or push this negative 2 with both pieces. Why? Because the 1/5 is inside the parentheses, and everything inside is affected by the outside. So 1 to the negative 2 power, 5 to the negative 2 power. There's my fraction. Now I flip it. Negative 2 goes on the bottom, but when the exponent changes sides, the sign changes. 5 negative 2 is on the bottom. It's going to go to the top, but the sign changes. 5 squared is 25. 1 squared is 1. So the answer is technically just 25. Now here's a couple for you to try. I want you to do like we've been doing. Try these problems all by yourself, and then come back and we'll check them, or you can check them as I work them. Okay. Let me yawn. Let me get a drink of water, and let's work these. Well, let's check them because you've already worked them. All right. 7 to the negative 2. First of all, I make it a fraction. Now I flip it. When I flip it, the sign of the exponent changes, and this gives me 1 over 49. Okay, I'm going to kind of block these off because I have a feeling I'm going to take up a lot of space here. Let's look at 2/5 squared. Now listen, 2/5 squared is just 2/5. When I have a positive exponent, I work it just like I normally would. The only time I have to flip anything is when the exponent is negative. So I put this one in here because what happens is when we're doing our homework or a test, we just sort of rush through and say, oh, this is what I'm supposed to do. I'm supposed to flip it. You only flip it if the exponent is negative. If it's not, we just work it regularly. And this becomes 2/5 times 2/5, or 2 squared, which is 4, over 5 squared, which is 25. Now let's talk about this negative exponent. Parentheses holds everything together. So I'm going to distribute or stick this -3 to both pieces. So there I've got my fraction. I've got my fraction organized. Now I'm going to flip it. When I flip it, the sign of the exponent changes. So the bottom becomes the top with a positive exponent. The top becomes the bottom with a positive exponent. And then I have 2 squared, which is 8. 3, not 2 squared, 2 cubed, which is 8, over 3 cubed, which is 27. And if your fraction can reduce, go ahead and reduce it. If it can't, like this one can't, just keep it. So the answer is 8 over 27. Okay, now homework. I don't know why the numbers look like that, but I don't know why it's not centered. I'm sure it's the person who designed it, which is me. There are 14 problems here. If you will work these and then bring them at our face-to-face tutoring time, we will go over all of these answers. Make sure that you've got them correct. If you have any questions, if you get stuck, if you want me to check them before you come in on Wednesday, just shoot me a text and we'll go from there.